video, we're going to derive the sum of cubes. The same thing can be done for a difference of cubes. I just am going through the sum of cubes because I think the signs are a little bit easier to use. This isn't something I'd expect you to do on your own, but it does fill in that hole for those of you who are wondering where the formula comes from. So, to derive the formula, which I already have on the board right here, we're going to divide a cubed plus b cubed by a plus b. And the reason we're doing that is because we know that a plus b has to be a factor of a cubed plus b cubed. Now, if I were to try to do this right now, the algorithm won't work out because I don't have the correct placeholders. So the placeholders that I need to use actually come from Pascal's triangle, which I have on the board over here. And I'm briefly going to explain how this is done. I'm sure there are other videos on YouTube explaining how to expand binomials from Pascal's triangle, but I think this is enough for you guys to understand the formula. So in the first row, I have a plus b to the 0 power, which is just equal to 1. This number matches this number right here. In the second row, I have a plus b to the first. Notice that this coefficient, the one on the a and the one on the b, matches the two values in the second row of Pascal's triangle. In the third row, I have a plus b squared. You guys should know that when you multiply a plus b squared out, you get 1a squared plus 2ab plus 1b squared. These coefficients are the same numbers in that row of Pascal's triangle. And then I went up to the third power because that's what we're going to use in our derivation over here. So a plus b to the third is 1a cubed, which matches that, plus 3a squared b. The 3 matches that. The next 3 matches that, and then we have 1b cubed. So this right here is what I'm going to use when I do my division. I'll be using different coefficients because this isn't equal to a cubed plus b cubed, but it's the same concept. So here, instead of writing a cubed plus b cubed, I'm going to write a cubed plus 0a squared b, because a squared b is my next placeholder, plus 0ab squared plus b cubed. So we're just going to go ahead and do regular polynomial division with this. So a goes into a cubed, a squared times a squared times a is a cubed, and then a squared times b is a squared b. And then we're going to go ahead and subtract this. So a cubed minus a cubed, those cancel out. 0a squared minus a squared b gives us negative a squared b. And then we're going to bring down our next term, so we get plus 0ab squared. And then we're going to repeat the same process. So we're going to ask ourselves, what do we have to multiply a by to get negative a squared b? And we have to multiply it by negative ab. So negative ab times a plus b gives us negative a squared b plus, or actually minus, ab squared. And then we're going to go ahead and subtract that. These two cancel out. Then we get 0ab squared minus negative ab squared, which gives us positive ab squared. And then we bring down the b cubed. And then we ask ourselves, what do we have to multiply a by to get ab squared? We have to multiply it by b squared. So b squared times a is ab squared. B squared times b is b cubed. Oh, and that should have been b cubed. And then when we subtract that, we end up with 0. So here we have that a cubed plus b cubed is equal to a plus b multiplied by a squared minus ab plus b squared, which is the same thing we have in the formula there.